So here we're told that secant theta is equal to 4. And because it's starting with secant theta equals 4, that makes it a grade 12 question because you're first looking at secant and you haven't done that before. Some of this part A is stuff you've done before. This is telling you your domain, that you're looking for an answer between 0 and 180 degrees. So if you think of your quadrants, and you think of your cast rule, we're only looking in quadrant 1 and quadrant 2. Now when we start this off, we're not used to secant, okay? But we know that secant is the reciprocal of which one? Cosine, okay? There's going to be two different ways that you're going to do this because it's a reciprocal, okay? Over time, what you're going to do the most is you're going to say, well, if secant is equal to 4, then cos is equal to 1 over 4 because they're reciprocals of each other. Sometimes you might change just the secant to 1 over cos. That would be fine as well. But then you'd have to multiply both sides by cos and divide both sides by 4, and you would get the same thing. All right. It's registration today. They've opened up a zoo course for next year. But if you rearrange this one, it will just get you this in the end anyways. So most people, when they're doing the reciprocal, if I know secant theta is 4, then cos theta will be 1 over 4. Now that we have that, this now becomes a grade 11 question. First of all, we recognize that cos is positive 1/4. So when we go to our cast rule, we know that, oh, I wrote the cast rule wrong. There we go. When we go to our cast rule, the C would be in quadrant 4, A, S, T. We would know that it is either in 4 or 1. It's in quadrant 4 or quadrant 1 because that's where cos is positive. But since we're only looking, our domain is from 0 to 180, we know that we're not looking in quadrant 3 and quadrant 4. So the only possible answer will be the answer in quadrant 1. So for this one, what we would normally do in a question like this is we'd go to our calculator. We'd hit our mode button to make sure that we were in degrees. And it's highlighted right now, so I know that I'm in degrees. And we always start, whether our fraction, in this case, it was 1/4, which is a positive number. Whether it's positive or negative, we'll always start by doing the inverse of the positive value. Because doing the inverse of the positive value is figuring out our reference angle, 75.5 degrees. Again, if you want to see what's happening, you can always draw a triangle. Since we've got 1/4 and we know that it's in quadrant 1, adjacent over hypotenuse, that's what's happening. Oops. Yeah, 1/4 adjacent over hypotenuse for cos. This is our reference angle, but in quadrant 1, our reference angle is the same as our angle. And so we get theta, what did I say it was, 75.5? 75.5. Okay, so 75.5 is our angle theta. Now we're to find the exact values of the other trig ratios. We're going to use that 75.5 coming up when we get to part B. But what are the other ratios? So again, I've drawn a triangle. A squared plus B squared equals C squared. We're missing the opposite side. Can you do that one in your head? Square root of 15. So when you know the hypotenuse, in this case that would be 4 squared, one of these side is 1 squared, you'll notice that you'll always take the hypotenuse squared minus the other side squared. So 16 minus 1 will be 15, and you get the square root of 15. So now to determine the exact values of the other trig ratios, well, we know cos already, so we have to find sine, tan, cosecant, cotangent, and of course we know cos already, but we can find secant. So the ratio for sine, opposite over hypotenuse will be root 15 over 4. For tan, opposite over adjacent will be root 15. Again, this angle here is your reference angle, and that's the angle that you use to figure out sine, cos, and tan. Yeah? And they gave us the secant at the beginning. That's true, we don't have to say that one, and we already figured out cos. So this one we already knew was 4. And cosecant will be 4 over root 15. And cotangent will be 1 over root 15. And since they're all in quadrant 1, because we knew that cos was positive, those will be the other answers. Now we need to the nearest degree, determine possible values of theta between negative 360 and 360. So at first we were only thinking about quadrant 1, but now from 0 to 360, if we think about 0 to 360, that's once around in the positive direction. And 0 to negative 360 would be once around in the negative direction. And if we have cos equal to 1/4, we've seen that it could be positive in quadrant 1 or quadrant 4. So here's our reference angle in quadrant 1. We would also have, here I'll draw them both, we know we could have 75.5 degrees this way. Does it say what I need to round to? To the nearest degree, so we can already make this 76 degrees. And we know that we could have a reference angle of 76 degrees in quadrant 4. So what are our possible angles? Well, let's do the positive ones first. If I was going in the positive direction, well, I would have 76 degrees for the one in quadrant 1. What would this angle be in quadrant 4 if I was going the positive direction? Hello.
Hi there. Could you please proceed to room B1 with your classroom for course selection?
Okay, we'll be right down. We'll finish this question right now, and then we'll go down. Okay? So 6, so you do 360 minus 76, and you'd get 284 degrees. Now, in the negative direction, might be obvious to see that that's negative 76 degrees, the same as the reference angle. And this one will act the same as the green one in the positive direction, will be negative 284 degrees. So that would be all the answers between negative 360 and 60. So the ones you can do for this one are 9, 10, and 11. And we'll go down to register.